suppose that we have some sort of binomial distribution. Okay, some sort of scenario where we have 10 fixed trials, where the probability of some success, some criteria, is a third. And let's just go through using the calculator, various tricks on the calculator to do all these kind of examples. So let's suppose you have this, in this binomial distribution, I want the probability that x is 5. So in other words, I want 5 successes, whatever the success is. Obviously the successes have as a probability of a third in any individual trial. Okay, what's the probability? I get 5 successes. So if you're looking for an exact amount of successes, in this case 5, then you use the binomial PD function. So what we do, go to your calculator, go to menu, you go down to 7, which is distribution, press equals. You could quickly just do menu 7, if you remember that shortcut. And you need this here, number 4, binomial PD. Binomial PD is when you have an exact amount of successes, not inequalities, but like we have here, x equals 5. So you press 4. Okay. Press 4, there we go. And it comes up with list and variable, go for variable. And it asks you to input this information. X is how many successes you want. So there's 5 in this case, you put 5. N and P is pretty obvious. It's exactly what you think it is, the amount of trials. And P, you can input it as a fraction. Okay, don't put 0.33 because this is actually 0.33 recurring. Best to put it in a fraction. Press equals. Right, and there is 0.1366. Okay, and that's the answer to that one. Right, to come out of this, you just press menu 1. Okay, now part B is probability x is less than or equal to 6. This is the exact scenario for the other binomial function on the calculator. So go back into where we are, menu 7. We use binomial PD. If you scroll down, you'll see there's an option binomial CD. Now, binomial CD is exactly for when you have probability x is less than or equal to something. Okay, probability x is less than, like we have here. So this exact scenario is what binomial CD is made for. So you press 1. Again, you go to variable. This time, because you're in binomial CD, the x you're looking for is not exactly how many successes you want. Okay, so x is not an exact amount of successes. It's all the successes up to and including that point. So if you have x is less than or equal to 6, then if you put in 6, you're not looking for 6 successes. It automatically accumulates, hence the name CD stands for cumulative distribution. So it's working out probability x is less than or equal to 6. Once again, you put in N and P, which is 10. Put in a third, that's equals. You put in a third. And there we have it, 0.9803. So we've said that binomial, let's go back into the function. So if we have a look here, we see binomial PD, number 4, that's when probability x is equal to something. And binomial CD is when it's less than or equal to something. So that's A and B, that's on a plate. But what about C, D, E, and F? These are all other scenarios that could occur, but doesn't fit the exact form of what binomial PD and what binomial CD is. So what do we do for part C? Part C says probability x is less than 8. So with all the other scenarios, C, D, E, and F, you've got to be able to use binomial CD. Right? We can't turn an inequality into an equality. So binomial PD, there's no way we can use binomial PD. But what we can do is we can say probability x is less than 8. Well, probability x is less than 8. Well, I can make that less than equal to, because if I want strictly less than 8 successes, that's the same as saying, okay, well, that's the same as saying less than or equal to 7 successes. Because if you're less than 8, you're not 8. So the next one down is 7, and then that will be inclusive. So you convert it into probability x is less than 7. And now you do like part B, right? You go into binomial CD, variable again. I've still got the data. I just need to change that to a 7 because I want 7 now. Press equals 9966. There we go. That's the answer. So the trick is to convert it into an inclusive inequality. Now, probability x is bigger than 3. Now that seems more of a problem because, okay, if you have bigger than 3, my binomial CD function is when it's less than. How do we deal with that? So the first thing you should always do, always convert it so it's an inclusive probability. So bigger than 3, the biggest problem you have is strict. So what we do here, strict, we turn it into inclusive, and then we can use binomial CD straight away. So we don't get something that we can use the calculator straight away, but it's definitely a better position to be in. So this time, if probability x is strictly bigger than 3, that's the same as saying x is bigger than or equal to 4. Because if you're higher than 3, the next one up is 4. And if you start from 4, that's the inclusive part. Now, let's draw a little diagram to help. Probability x is bigger than or equal to 4 means 1 minus probability x is less than or equal to 3. Let me show you why. Okay, so look at this diagram. If probability x is bigger than or equal to 4, it means we want to add up all those probabilities. Okay, all the blue ones. Okay, so 4, 5, 6, 7, 8, 9, 10. I want probability x is 4, 5 up to 10. I want the entire probabilities added up in that oval. But it's easier to say, okay, well, what are the orange ones? 0, 1, 2, and 3. Those are the ones I don't want. I want all the others. So what I don't want, plus what I do want, all those probabilities add up to 1. So therefore, let's work out the probability of 0, 1, 2, 3, which is less than or equal to 3. And then you just subtract it from 1. So that's how I get 1 minus probability x is less than or equal to 3. So if we go into our same function again, okay, what if I always write down what you're doing first before you use the calculator. This is methods, right? This is part of the method. Okay, very important. So you type in 3 equals, okay, and you get 0.5593 rounded. However, we need to do 1 minus that. Okay, now in the statistics function on the calculator, you can't do 1 minus here. Okay, but what you can do is the calculator will know that your answer is 0.5592. So if you come out of this, press menu 1, comes out of this, and simply do 1 minus that value. Okay, okay, and that's the answer. Okay, 0.4407. Okay, now part E is arguably easier than D because it's already inclusive. Look, it's already inclusive. And what do we do in part D? When it's inclusive, I can just do 1 minus 1 down. Okay, because this time I'm doing 1, 2, 3 up until 10. So what do we say? Once it's inclusive, let's think what I don't want. It goes from 1 and above. The only one that you won't capture in that probability is 0. Okay, if you look at this, okay, so let's look at, okay, okay, in a similar way, okay, so you do 1 minus, instead, this time this occasion it was less than or equal to. There's no point writing less than or equal to 0 because you can't be lower than 0, so it's simply 1 minus probability x equals 0, okay. Now probability x is equal to 0 and probability x is less than or equal to 0 is exactly the same, so it doesn't really matter what I go for now, PD or CD. I'll just do PD, but you could arguably do CD, so you do 0, 10, a third, which is that. Okay, and I need to do 1 minus that. Okay, so come out of this, 1 minus that, which is 9827. Okay. Now, another thing is what happens if your probability is bounded by 3 and 7. It's a probability of x taking the values between 3 and 7. So here, again, you should see a common theme. What do we need to do? We need to make sure all our probabilities are inclusive. Look, this was inclusive, no problem. This wasn't, I made it inclusive. This wasn't, I made it inclusive. This was inclusive. See, there's a pattern. Always make it inclusive. So we have to do the same here for both. Okay, it's 3 and 7, between 3 and 7, but 3 is not included, and neither is 7. So if 3 is the lower number, the first one that would be included is 4. If 7 is the higher number, the highest number that would be included is 6. But then what do we do? So if we've established our probabilities between 4 and 6, I can't really deal with this range between 4 and 6 on the calculator. There's no function for that. So what we do instead, okay, is let's look at this diagram. I want the blue probabilities, 4, 5, and 6. We'll do something quite clever. If we work out the probabilities of 6 going all the way down to 0, that sounds like probability x is less than 6. But that's too many because I've picked up the 3, 2, 1, 0. The orange ones, that wasn't part of the probabilities I wanted. So let's remove that. The 0, 1, 2, and 3, which I've now unfortunately got in this 0, 1, 2, and 3, that sounds like probability x is less than or equal to 3. 3, 2, 1, 0. Let's take that away because I don't want them. Like that. And then you work out each of these separately because I'm now in the territory of x is less than or equal to. Okay. And work out the properties on the calculator in the similar way. Menu, 7, binomial CD, variable, type in 6 first, 10, third, which is 9803, and you do something similar for the 3. Okay, 5593, and you get the answer. Okay, write down each one separately for working. Okay, it's worth saying at this point that when you get a number, okay, if you don't want to lose it, okay, although it's very important to write down the numbers you get throughout a calculation, you can store it in the calculator. So let's say I had the 0.9803. You got that number there, okay? And I want to do something else on the calculator, okay? So I would say I'm in the statistics function and you press menu 1 and you come out of it, okay? But I don't want to lose that, okay? So what you can do here is you just press store, okay? And you can see here, there are these red, if you see in red, A, B, C, D, F. So you just choose any of them, press store and then choose them, okay? Now look what the calculator does. It's basically told you that A is now that answer. So come out of this, press AC. If I want to use A, okay, because it's in red, it corresponds to alpha. So press alpha A. Let's try again, alpha A. There we are. And you can do, and then let's say I want to add that to something else, 6.2. Okay, it'll do it for you. So I want to subtract. Okay, so you could store this, for example, and then you could minus that. Okay, so you don't have to lose answers. Okay, that's quite effective. Yeah, 0.421. Okay, remember statistics probabilities have to be at least to 3SF. There's a convention to write probabilities to 4 decimal places like I've done because that's definitely good practice. Also, if you write it to 4 decimal places, you're at least most of the time you're at least to 3 significant figures. So obviously, if there's loads of zeros at the front, you'd have to be careful. But if you just write to 4 decimal places, with the exception of numbers that have loads of zeros at the front, then you should be safe.